Today, we are going to explain how to connect HUCEEN's 100 CPU to HUCEEN's HD200SP distributed I/O module. This is the network cable. First, let's connect this network cable to the computer. This is a base. The base is divided into white and black types. Here, we only have the white one. Ours is a 2-in-1 unit, meaning these two are integrated as a whole. The white one requires an external power supply, while the black one does not. It gets power from the left side, coming from the bottom layer. This is our module. In a moment, we'll plug it in. Once it's plugged in, the light here will also turn on, indicating that it has power, though it's not very obvious. Alright, next let's look at how to configure it in the software. First, we create a new CPU and select version 3.0. Here, we can learn how to do it. Okay, let's add a network. For the network, we need to find 200 SP, which should be this one. It's this one here. Find the perfect net interface. Here, the ST standard configuration is for 6AU01. Now let's drag it over and first set up the network connection. Let's first configure the modules inside because we've set up two 16-channel output modules. Alright, one white and one black. The base is fine. Let's check its address. The address is QB2345. Okay. Now let's download and check if the connection works properly. After that, we'll write a program to control the output of the points. Alright, this is 120. That's fine. Let's check the online status. One thing to note is that when doing distributed L1, you must check whether its IP and the name of the Profinet are correct. If they are not, we need to set them again. Here, it's already correct, so that means there's no problem. Right now, it's still showing a red error. Let's see what the reason is. Now, it's normal if sometimes the communication time causes it to disconnect, or if the situation on site is different, we can also adjust the IO refresh time at the back, maybe make it a bit longer. For example, we can change it to 16. This way, it will be more stable. Alright, now we've already connected. Now let's write a simple program to control it. We'll still use the old method. We'll create a pulse output to make it work. Still, we'll put the clock move here. Just now it was QB2. I'll put it at the end and we'll write 255. Alright, copy this for QB3, QB4 and QB5. Similarly here, we need to use the rising edge to trigger it. Okay, let's copy this section of the program and then we'll add a falling edge to reset it to 0. Fill all of these with 0. Alright, let's download it again. First, stop the CPU, stop it before downloading. Alright, let's run it and check the pulse. It hasn't executed here, hasn't executed, so let's recompile both the hardware and software. Okay, this will take a moment. Maybe the CPU is still connecting. Now it's normal, right? No errors, and the program is running. Let's actually see its effect. Here the pulse output is at several addresses. Yes, it's because of the lighting here, maybe that's why it's not so bright. Right now there are no alarms either. Everything is normal. And our system also supports hot swapping. For example, if we unplug it now, then our CPU will give an alarm. Yes, it will alarm. But this module will still run normally. Let's plug it back into restore normal operation. Now the alarm has been cleared, so there are no more alarms. Alright, that's all for today.